前回の動画で話した通り、今日はプレゼンをします。エネルギーをつけるためにお腹いっぱいご飯を食べます。8時頃会場に到着しました。ここは高校です。生徒たちがネットボールの練習をしています。受付をします。集合時間なのに人が少ないです。文化会で発表と聞いていましたが、私の名前がありません。なんとプリントの反対側のメイン発表者のところに私の名前がありました。教授たちと同じ並びにあるし、予想外ですし、結局120人くらいの先生たちが集まりましたし、だんだん緊張してきました。でも頑張ります。よければ見てください。
My theme is education in South Africa in comparison with Japanese one. I'm going to make a presentation right now. First of all, I will introduce myself. My name is Tomoyuki Inoue. Please call me Tomo. Japan, do you know place Japan? Japan is here. Japan is located in Far East of Asian Union. Yes. And do you know karate? But I have something to apologize to you. I never tried karate, so I cannot teach you this karate. Sorry. Do you know kung fu? Kung fu is from China. Yes. So most of South African people misunderstand that Japanese and Chinese are same, but we are different. Actually, Japanese people, including me, cannot understand Chinese language, so we are different. Thank you. Now I belong to the Autism Science Center in Mpumalanga, but I also VOCB. VOCB means Japan Overseas Cooperation Volunteers. I'm a member of VOCB. That is why I'm here. And then it has passed about 10 months since I came to South Africa. Before coming to South Africa, I was a high school teacher. My subject is, of course, mathematics. My previous educational system. This table is Japan's educational system. In Japan, there are kindergarten, preschool, elementary school, junior high school, and so on. Elementary school and junior high school are compulsory. I think which is the same as that of South Africa. This table is daily schedule of high school, but it's just one example. Daily schedule depends on the school. For example, students come to school take homeroom, first class, second class, short break, third class, fourth class, lunch break, fifth class, sixth class, homeroom. From here, after school, some students clean up their school, and some students do club activities. And this table is timetable of first grade of high school. But it's also just one example. Thank you very much. That's all for my introduction. From here, I will make a presentation about my topic. This one is today's program. I will make a presentation according to this program. The first one is math education difference between South Africa and Japan. This table is about grade, subject, and class hours of 200. As you can see, Japanese class hours are less than those of South Africa, like this. And I have something that I should talk to you about high school subject. Only mathematics 1 is compulsory from students to graduate from their school. They can choose if they study or not mathematics 2 and 3, A, B, and C. But most of schools make students study mathematics A and 2. And this table is about comparison of rules. Japanese students are not allowed to use a calculator. Yes. And Japanese test and Japanese examination don't have information sheet. Yes. And this one is based on content. I found a lot of difference to countries mathematics education. For example, South African students study quadratic sequence, but Japanese students study not quadratic sequence, but also some kind of difference, some kind of sequence. For example, the top one is quadratic sequence because difference is 1, 2, 3, 4 all the way, which is arithmetic sequence. In contrast, the bottom one is not quadratic sequence because difference is 1, 2, 4, 8, 16, 32 all the way. Japanese students study some kind of sequence like this. But Japanese students don't study finance at all. Don't study finance at all. But Japanese students study high-level integration, such as derivative of composite function, derivative of inverse function, integration by substitution, integration by parts, so on. Japan is behind of South Africa in terms of study irrational equations. But Japanese people study some kind of inequality, such as exponential equality, logarithmic equality, trigonometric equality, irrational equality, and so on. And I found a lot of differences about friendship topic. About space figure, Japanese students study Euler's polynomial formula. This is the last about statistics. Japanese students use the sign of P and C when they study permutation and combination. And I found a lot of differences also in method. For example, this one is about factorizing quadratic. This one is Japanese method. We use acx squared plus ad plus bcx plus dt is equal to ax cubed plus b times cx plus t. We use this formula. we look for the values of A, B, C, and D such that AC is equal to 6, BD is equal to negative 12, AB plus BC is equal to negative 1. We look for the values like this by the diagram like this. We use the diagram. And this one is next example, which is about solving general term of quadratic sequence. This is a Japanese method. We use this formula. AN is equal to A1 plus the sum of GK, such that K is equal to 1 up to N minus 1. We always use this formula. And this one is about finding the unknown signs or angles by using trigonometric ratio. This is Japanese method. To solve for x, for example, to solve for x, question number 1. Japanese people write x is equal to 50 times sine of 20 degrees, which is the same of that of South Africa. But from here, we use the table of trigonometric ratio like this. Because of no calculator, we find the value of sine of 20 degrees, 0.3420. So Japanese people write sine 20 degrees is nearly equal, not equal, nearly equal 0.342. Therefore, x is equal to nearly equal to 50 times equal to the answer is 7 equal to 1. This is last example, which is about sketching the graph of cubic function. This one is Japanese method. We always use derivative gesture like this. Let me explain about it. The first law is value of x. The second law is f prime of x, which means gradient of tangent the graph. And thus, the last law is f of x, which means y value or shapes of the graph. So look at this. Increasing stationary point, decreasing stationary point, increasing. Increasing stationary point, decreasing stationary point. Like this. So we don't need to solve for the value of x-intercept because y-intercept and stationary point are enough for us to determine the cubic function. Yes. This is summary of my perspective. In my opinion, South Africa curriculum is designed so that all students can learn moderately in small steps. In contrast, Japanese curriculum is designed so that students can learn deeply according to their own characteristics. But just in my opinion. That's all for the first program. Let me move on to the next program, which is progress of South African mass education from my perspective. This program has two topics, which are students for calculation skill and students for mathematics skill. I'll explain about the first one first. When I observed math classes, I see that grade 5 students of nearby secondary school made a mistake in 100 minus 37. And grade 7 students couldn't answer 7 and 6 quickly. And grade 9 students couldn't calculate 40 divided by 8 accurately. Incidentally, only 6 students out of 49 could answer it. So I started my research. Actually, I have special class. So I don't work at school. My students are top achievers of nearby secondary school. In my first class, I made them I made them work on writing test of basic calculation and basic algebra. Like this. For example, addition, subtraction, basic multiplication, two-digit number times one-digit number, two-digit number times two-digit number, division, calculation of decimal fraction, calculation, common fraction, and quadratic formula. And at that time, I gave them enough time. I decided the time 1.5 to 2 times as long as the time which it takes me to get correct answer, like this. And at the day later, I also made them revise their incorrect answer by same rule. This is the result. This one is question. This rows question. This rows number and rate of correct answers. I marked the blank circle is question whose answer is low answer. I marked like this. I'll show you some examples of students' answer. For example, this one is addition and subtraction. Look at this. Some students' answer are blank. Some students' answer were blank. Or some students got incorrect answer. But after revision, some students got correct answer. From this one, I found some South African students couldn't do calculation, addition, and subtraction quickly and accurately. This is the next example, which is about basic multiplication, at least 9 times 9. At least 9 times 9. Sorry. Look at this one. Some students' answer are blank, or some students' answer. Some students got the correct answer. So from this one, I found when they do multiplication, they counted from first. For example, special number 17. Then they tried 7 times 6. They counted from 7 times 1, 7, 40, 21, 28. That is why students got correct answer, especially questions over half. And this one is last. This question is about two-digit number times two-digit number. In first attempt, no students got correct answer. Even after revision, only 20% of students got correct answer. And the bottom one is 589 divided by 31. In first attempt, only 10% of students got correct answer. Even after revision, only 30% of students got correct answer. From this I found some students couldn't understand, couldn't remember how to column method, how to learn division. And then after examination, I also make them quiz about daily life like this. For example, this one is about shopping, which is cheaper. But about 1.1, less than 50% of students couldn't find how much cheaper. About 1.2, only 30% of students find how much cheaper. This one is the last example, which is about time management. I gave them how long it takes to bus stop from home, and I also gave them bus and train schedule. But more than 50% of students listen to their Yeah, so I think, in my opinion, students' core calculation skill is one of the problems of South African calculation education. Because if they go on like this, for example, when they become adult, they may be cheated by someone. They may not be able to estimate their salary or their living expenses. Yeah, sorry, just my opinion. Yes. Actually, mathematics caps in the case grade say to us the method mathematics should systematically develop three aspects of learning: number knowledge, times tables involving multiplication of whole numbers to at least 10 times 10. And mathematics caps senior phase also says to us learners should do context-free calculations and solve problems. For example, 3 over 4 times 2 over 5 is equal to 3 over 10. And mathematics caps LED also says to us the first specific aim is to develop frequency in computational skills without relating on the usage. So I think from this side, students' for calculation skill is one of a big problem of mathematics education. I explain the next one, which is students for mathematics skill. I've seen grade 12 students of nearby secondary school didn't doubt their storage answers like this. This function is quadratic, so this shape of graph must be parabola, but they didn't doubt like this. And I've seen students of secondary school didn't know the reason below. For example, when I asked a student, do you know the reason? 2 squared times 2 cubed is equal to 2 to the power 5. Some students didn't answer. Some students told me because of the law, because of the formula. But I think the law and the formula is not the reason. So if we write 2 times 2, 2 times 2 times 2, we got 2 to the power 5. Very easy, but they didn't answer. They didn't answer. This is last. I've seen grade 10 students work roughly. This question is find the unknown sides and angles correct to decimal places. To solve for A, the angle of A, cosine A is used. Cosine A is equal to 4.3 over 9.7. And then 4.3 over 9.7 is equal to 0.44. And then A is equal to inverse cosine of 0.44. A is equal to 63.9. But in my opinion, it's almost wrong, unfortunately. Because so 0.44 is not accurate number. We must write A is equal to inverse cosine of 4.3 over 9.7. Yes. So that is why not accurate answer. That's all for the next program. Let me move on to the last program. This one is the reason and solution of the problems appears in Japanese education and my experience. This program has 2 topics which are about curriculum of calculation and about teaching way. I'll explain about the first one. Sorry for tiny sentence. This one is curriculum of calculation. Curriculum of calculation. The top one is South Africa, the bottom one is Japan. South Africa is behind Japan in terms of starting to study multiplication of whole numbers to at least 10 times 10. In Japan, students start to study at least 10 times 10 multiplication at grade 2. So almost all of students remember. But in contrast, in South Africa, which is at grade 4, finish 4. About decimal number, South Africa is behind of Japan in terms of starting to study. Japanese people study decimal number at grade 3. South Africa is grade 6. Fraction is also. And I found many differences in method. In Japan, there are only 4 methods, only 4 main methods, which are adding columns, subtracting columns, multiplying columns, and long division. Japanese students practice calculating by using these words again and again. In contrast, South Africa, there are many methods. So even, I think, in my opinion, it makes students confused. Yes, actually, when I asked one teacher of primary school, she told me the same thing. Yeah, actually, students are confused. Learning multiplication table from 1 times 1 to 10 times 10 and the column method is laid causes the opportunities to practice multiplication in column and row may overwhelmingly be short for students. In my opinion. I'll explain the second one. I've seen like these ones several times when I observe mathematics classes in nearby school. Students don't understand something. Students struggle with questions. Students run short of time to practice questions during class. And students use calculators and in my opinion, teachers should observe students' atmosphere, skills, homework, and answer individually. And teachers should teach and help students individually. So I think especially for students whose skills are very important. Most of Japanese teachers help and teach students individually, even after school. Yes, but in my opinion, so I always teach and help them, my students, individually. Almost finished, yes. This is the last topic. And our teachers should give students more opportunities to practice. This one is one of the examples of my class for 15 minutes. I always first spare 1 minute to explain today's goal or program. Because I think it's necessary step for students to prospect the class. For example, today, let us study something. Today, let us practice something like this. And then I spare 10 to 15 minutes to explain a new notion or example. And then I spare 15 to 20 minutes to make students work. This time, students work on similar questions to example. Students ask questions to me or their friends. As I said before, practice something is very important. Practice something again and again is very important. So I always spare this time. And then I spare 5 minutes to show students the answers. This time students check their answers and revise the incorrect answers. Practice something is very important. But I think checking and revision are also very, very important. So practice, check, revise. 3 steps are very, very important. And then last, I spare 4 minutes to show the summary of today's contents. This time, students review their work of the day. Yes. Let me go back. Sorry. In my opinion, teachers should make similar questions to the examples. I was surprised a little. This one is from a South African textbook. This one is one example. This one is exercise. Sorry, can you sorry. Question number 1 and question number 8. These ones and examples are not similar. Actually, I can solve these questions without one example. So I think it also makes students confused. But this one is from a Japanese textbook. Top one is example. Sorry, this sentence is in Japanese. Top one is Japanese. Example. The bottom one. Exercise. These questions and these questions are similar. Incidentally, question number 1 and question number 2 are easier, and question number 5 and question number 6 are more difficult. So they are made step by step. Sorry, this is example. This is also from South African textbook. This one is example, this one is exercise, but they are extremely different. This is example is about proving. This one is so and what? Yes, extremely different. This one is from a Japanese textbook. Let me translate this example in English. Right below, if BE is equal to BC, solve for the value of GT. This one. So this one and this one, this one and this one are similar. This one and this one almost similar. Yes. Let me go back. Teachers should make students use calculator appropriately. The result of my test, this is another half, Clear shows that even grades can the result of my test clearly shows that even grade 10 top achievers have extremely low understanding of the contents from grade 6. So 0%, 3%, 7%, these questions. Let me do summary. I talked about math education differences between South Africa and Japan, such as educational system, daily schedule, and timetable. Next, I talked about problems of South African math education from my perspective, which has 2 topics. The first one is students for calculation skill. The other one is students for mathematics skill. Last, I talked about the reason and solution of the problems in comparison with Japanese education, which also has two topics. The first one is curriculum of calculation and teaching way. Thank you very much for listening to my presentation. Sorry,
プレゼン後、研究レポートを欲しい先生へ配布しました。すごくかっこいい証明書ありがとうございます。実はプレゼン後にこのようなアンケートを取りました。ただ60枚しか用意しておらず、全員へアンケートできませんでした。さらに会場を早く出なければいけなかったので、29枚しか集まりませんでした。これらはアンケートの集計です。多くの方が私のプレゼンを理解してくれて満足してくれました。すごく嬉しい感想をいただきました。これら以外にも数名の先生からお褒めの言葉をいただきました。あなたの分析はすごくいい。情報をたくさん得た。我々のカンファレンスでも発表してほしいなど言っていただきました。これらはアンケートの回答を一部抜粋したものです。教科書の会社からもサポートが欲しいと言っていただきました。私が少しでも先生や南アフリカ共和国の数学教育の役に立っていると思うと、本当に幸せな気持ちになります。この機会をくれた同僚に感謝しています。実は3ヶ月後に追跡調査もしました。私が少しでも役に立っていることを改めて感じ、本当に嬉しく思いました。以上、私の認知での活動25編でした。ではまた次回お会いしましょう。